Welcome to The Explainer. Today, we're diving into something that is honestly completely unprecedented in the AI space right now, and that is Anthropic's Claude Fable 5. The story of this model, it isn't just about raw computational power. It's actually this fascinating tale of extreme engineering, some pretty intense hidden dangers, and a massive last-minute pivot. So, let's just jump right in.
Think about this for a second. Just 2 months ago, Anthropic looked at this exact model and essentially said, no way. This is way too risky to ship. They put a hard stop on the whole thing. Yet here we are today, and that very same model is live and available for everyone to use. That is a complete 180-degree turn in just 8 weeks.
So it really begs the question, right? Why was Fable 5 originally refused? What was it about this specific model that made one of the leading AI labs in the entire world just slam on the emergency brakes? Well, to understand the fear behind that decision, we first have to understand the sheer scale of its power. We really need to look at what Fable 5 can actually do.
Section 1. Mythos-class capabilities.
So Anthropic isn't even calling this an Opus or a Sonnet-level model. Fable 5 actually operates in an entirely new tier that they're calling the Mythos class. This sits way high above previous models like Haiku 4.5, Sonnet 4.6, and even Opus 4.8. And its sheer dominance really comes down to 3 distinct areas of mastery: long horizon tasks, vision, and memory. Let's break these down one by one, because this is where things get truly incredible.
First up, long horizon tasks. Most AI models are great at sprinting. They start super strong on a big task, but then they just drift completely off course a few steps in. Not Fable 5. During early testing, a company literally handed this model a codebase of 50 million lines and asked for a full system update. Fable 5 finished the entire job perfectly on track in a single day. To put that into perspective, a human engineering team doing that by hand would have needed over 2 months. It doesn't just do the work faster, it fundamentally refuses to lose focus.
Moving right along to its second superpower, which is vision. Fable 5 is currently the strongest model on the market for visual tasks. Hands down. It can effortlessly pull exact numbers from dense, incredibly complicated scientific charts. But the real kicker here is how it handles digital environments. Older AI models needed a lot of hand-holding to play a game, right? They needed separate, special data feeds for maps, game states, coordinates, the whole shebang. Fable 5 doesn't need any of that. It played through an entire video game just by watching the screen, identically to how you or I would play it. No extra data feeds required whatsoever.
And finally, let's look at the third strength, memory. When you compare Fable 5 to the older Opus 4.8 on that exact same gaming task, performance doesn't just improve a little bit, it literally triples. And why is that? Because on long, messy tasks, Fable 5 actively keeps track of what it has already done. It writes itself notes to improve as it goes. It acts way less like a calculator and a lot more like a focused human collaborator. That active memory gives it a staggering 3x utility improvement over Opus 4.8.
Section 2. The danger of extreme capability. Now, those 3 capabilities we just talked about are absolutely breathtaking, but they're exactly why Anthropic initially delayed this launch. You see, Fable 5 is actually the second Mythos-class model. The first was an early preview released earlier this year through something called Project Glasswing. The public never even got access to it. It was strictly limited to a tiny group of highly trusted organizations. Because when an AI gets this smart, releasing it suddenly becomes a profound safety decision, not just your standard product launch. Which brings us to this really fascinating dual-use dilemma. What makes a model unsafe to release? Usually, it's because the most useful requests are inherently dual-use. Take biology, for example. The core skill of predicting how a genetic mutation changes a virus's outer shell is incredibly valuable. On one hand, researchers can use this exact same skill for life-saving gene therapy research. But on the other hand, a bad actor can use that identical capability to design dangerous pathogens. It is the exact same underlying skill, just pointed in 2 very different directions. But, dual use alone isn't the whole story here. Anthropic was really truly terrified of a concept called uplift. Now, uplift means giving someone a capability edge they could not get on their own, something far beyond what they could find with just a basic internet search. If a bad actor asks an AI a dangerous question, and the AI just gives them an answer they could have Googled in 5 seconds anyway, the model hasn't really changed the threat landscape. But if the model acts as a personalized, genius-level scientific collaborator for a malicious project, providing complex, completely unattainable knowledge, that is massive uplift. And that is what actually changes the global threat landscape. Section 3. Solving uplift with classifiers.
So how did they fix that uplift problem to actually make a public launch safe? The elegant engineering solution was building a protective shield around the model using things called classifiers. Think of classifiers as completely separate AI systems whose only job is to act as bouncers. They're watching every single incoming request and flagging potential misuse before the main Fable 5 model ever even sees the prompt. These classifiers are specifically trained to hunt for three things: cybersecurity threats, biology and chemistry misuse, and distillation, which is essentially when someone tries to illicitly copy the model's abilities by training another AI on its answers.
And here is where Anthropic did something incredibly clever. When a classifier flags your prompt, you don't just get a giant frustrating access denied error. Because flat refusals are a terrible user experience, right? Especially since classifiers can sometimes be overly cautious and accidentally flag completely harmless requests. Instead, flagged prompts are seamlessly rerouted to a slightly less capable model, Opus 4.8. So 95% of the time, users are getting the full, unrestricted power of Fable 5. But for that roughly 5% of flagged requests, you smoothly fall back to Opus 4.8. You still get an answer, you don't hit a brick wall, but the system successfully denies massive uplift capability to potentially dangerous requests.
And just to show you how modular this safety shield really is, let's quickly consider Fable 5's sibling model, Mythos 5. Under the hood, they're the exact same core model. The only difference? Fable 5 uses the full suite of classifiers for public use, while Mythos 5 actually operates without the cybersecurity classifier because it is strictly deployed in highly trusted, heavily gated enterprise environments. They literally just toggle the safety layers on and off based on the trust level of the user.
All of this leaves us with this incredibly important question. Is gated capability and seamless rerouting the new standard for frontier AI? Because the real innovation of Fable 5 wasn't just its massive memory or its crazy ability to code for 24 hours straight. It was proving that you can take a model that is arguably too dangerous for the general public, wrap it in a really smart routing system, and ship it safely without ruining the user experience. As AI gets even more powerful, is this how every major model will have to be released from now on? Thank you so much for joining me for this explainer. I really hope this completely changes how you look at the incredible tech behind Fable 5.